Hello and welcome to random charge coupled devices calculations. Okay, so here we've got a very small pixel, right? Remember, a square meter is really big, though, right? It's got a huge capacitance, and it's picked up this much charge, right? And so the first question is, what's the voltage across it? Then we want to know how many electrons were displaced from the pixel. So we're going to basically turn that charge into electron charges, right? And then the question is, what is the photon flux in photons per square meter incident on the CD? I guess you'd have to say per second here. So let's assume this was like a 1 second exposure. Okay, so our first question is, what is the voltage? Well, voltage capacitance is Q over V, so therefore voltage is Q divided by C, right? So that is 3.45 times 10 to the minus 14th coulombs divided by 2.3 times 10 to the minus 12th, and that is coulombs per volt, is what a farad is a coulomb per volt. Okay, so 3.45 E minus 14 divided by 2.3 E minus 12, and I get 0.0015 volts across that, yes. Right, and then we want to know, what's our next question? Our next question is, how many electrons were displaced? Well, all that question is how many electrons are there in this much charge, right? So number of electrons is 3.45 times 10 to the minus 14th coulombs divided by whatever charge per electron is, right? 602. This is electrons. Coulombs per electron, right? Okay, so 3.45 E minus 14 divided by 1.602 E minus 19. And that's a lot of electrons, 2.153 times 10 to the 5th electrons. Now the question is, how many electrons are, if each one of those was caused by a photon striking the CCD device, how many photons per square meter is that, right? Well, here is how many square meters it is. Photons per square meter is just photons, which is this, right, divided by that, right? So is going to be that many photons, right? We're going to say every electron was displaced by one photon. Right? This is not entirely true, right? 10 to the 5th photons. And then how many square meters is it? Well, darn few, darn little. 3.1 times 10 to the minus. Okay, so I'm going to take this guy and divide by 3.1 e to the minus 10th square meters. Oh, whoops. I didn't divide it by, I raised it to the power of, okay, hold on. I'm getting back there. There it is. Okay, how about divided by? 3.1 e minus 10. And I'm getting 6.94696 times 10 to the 14th, and that's photons per square meter. Ta-da! Okay. So let's do a harder example. And this one's going to be done in parts. Okay. And then, by the way, a sunny day is about 3 times 10 to the 21st photons per second. I think I figured that out. Anyway, I hope that's right. That much force. Oh, that's interesting. Okay, so so here's a Nikon D3X, right? What's the area of each pixel? Well, if it's this by this, right? Okay, then it's going to be 35.9 times 10 to the minus third meters, right? Right, times 24 times 10 to the third, right, meters, divided by a lot of pixels, right, divided by 6048 by 4032, right? So let's do that. 35.9 e minus 3 times 24 e minus 3 divided by parentheses 6048 times 4032. Okay. And I'm getting that that is equal to 3.533 times 10 to the minus 11th square meters per pixel. Those are small pixels. What do you suppose the next question is? Okay, if the light with a photon flux of that many photons per square meter per second is incident on the sensor for 1/250th of a second, what is it? Oh my god, that's hard. Okay. I think what we do is we multiply this by the area, which we've got here, right? Okay. Okay, that will give us, and then we've also got to divide by 250, right? So here's what we're going to do. We're going to go 4.5 times 10 to the minus 19th, and this is photons per square meter per second, right? Let's let the units guide us here. We know, okay. And then we're going to multiply that by our area, which is 3.533 times 10 to the minus 11th. This is square meters, right? Okay, then we're going to multiply by 250th of a second, right? Okay, what do we have now? Let's see, we got square meters go the way of the bison, right? Seconds goes the way of the bison. I guess we're going to, we're going to get photons. That's what we're going to get. And let's assume that it's 100%, 70%. Oh dear. Now we're in trouble. We've got to assume it's 70% efficient. Okay, so let's do this calculation here. That times 4.5. Oh, that's not negative 19. That's positive 19, right? So 4.5 e to the 19, right? Yeah? And then divided by 250, right? And then since it's, by the way, since it's 70% efficient, only 70% of those get captured, right? So I'm going to say times 0.70. I'm going to add that into the mix, right? So let's see. Divided by 250 times 0.7. Okay, this is going to be the number of electrons. And that is 4.452 E6 electrons, right? Okay, now my charge is going to be, what's it going to be? It's going to be that number I just got, 4.452. It's on my calculator, right? 10 to the minus, to the positive 6. I've been doing that all night, okay. Times, let's see, 1.602 minus 19, right? So times 1.602 E. And that is 7.13 times 10 to the minus 13th coulombs. Yay, thank heavens. Okay, so now we've got that. Okay, that's good. So let's go to the next slide here. If the voltage is that much, what's the capacitance? Well, C is Q over V. And we just got the charge, right? Right, so that's going to be divided by, the voltage is 2.4 times 10 to the, oh, this is minus 13th. There we go, 10 to the minus 3, right? So divide this number on my calculator by 2.4 E minus 3. And that's 2.972 times 10 to the minus 10th farads. My gosh, will this never end? Will this problem never end? Okay, so let's see. I am, and my image is 19.2 millimeters tall, right? So it's, it's well framed in the picture there, right? What's the magnification? Well, magnification is image size over object size I'm going to use this formula as long as you don't object. We've got to be objective about this. We don't have an image to uphold. Okay, so the image is 19.2 times 10 to the minus third meters, because that's what millimeters means. And this is 183 times 10 to the minus 2 meters, right? So let's go 2e minus 3 divided by, okay, 19 divided by, well, that's really 1.83, right? Okay, so that is equal to 0.01049, so I'll say 5 times, right? It's 1% as big, right? Something like that, right? All right. Hey, there's the thing. We got it. Look at that. We got the right answers. Aren't we smart? All right.